Our next topic is graphing parabolas, and this is part 1. The little icon here that is shown above the word graphing is what a parabola is. It's also known as a quadratic function. The graph of a quadratic function is called a parabola. Okay, so our objectives in this session are to understand the x-intercepts and zeros of a quadratic function, and then we'll also understand if a quadratic function opens up or down. Okay, so quadratic functions. So before in this class we talked about quadratic equations, which came in the form of ax squared plus bx plus c equals 0. Now what we're talking about are quadratic functions. So we have f of x is equal to ax squared plus bx plus c. And of course a can't be 0 or else we would lose the x squared. Okay, so the graph of a quadratic function is called a parabola. So x-intercepts and zeros of parabolas are quadratic functions. So x-intercepts are ordered pairs. X-intercepts are where the graph intersects the x-axis. With that, on the x-axis, y is equal to 0, so the y-coordinate of the intercept is 0. And it's possible to have no x-intercept, one x-intercept, or two x-intercepts, and we'll see that as we go through the examples. Okay, so 0, so our x values where f of x is equal to 0. So notice, with our quadratic equations, if we were talking about functions, we would have found, when we solve, for x, we would have found where the function is equal to 0 or the zeros of the quadratic function, okay? And another way to think about it is it's the x-coordinate of the x-intercepts, okay? So x-intercepts are ordered pairs, zeros are the x values. Example 1, use the graph of f of x to find the x-intercepts of the graph and the zeros of the function. Okay, so the x-intercepts are where the function intersects the x-axis, so it's at these 2 points here. So this first one is at 3, 0, and the second one is at negative 3, 0. So we would write those as ordered pairs separated by commas. Okay. So the zeros of the function are where the function is equal to 0 or where the y is equal to 0. Okay. And so or just the x coordinate of each of the intercepts, and these are written as values separated by commas. So the zeros are x is negative 3 and 3. This is an example of two x-intercepts. Example 2, use the graph of f of x to find the x-intercepts of the graph and the zeros of the function. Okay, so in this case, we only have one x-intercept. It is here at negative 2, 0. So my x-intercept is negative 2, 0, and the x value where the function equals 0 is x is negative 2. So this is an example of one x-intercept. Okay, example 3, use the graph of f of x to find the x-intercepts of the graph and the zeros of the function. So the x-intercepts, in this case, there are none. Okay, remember this is our x-axis. This graph is never going to cross it. Okay, so there are none, and there are also no zeros. So this is a case of no x-intercepts. Okay. So next, maximum and minimum values of a parabola, and this relates to if a parabola is opening up or down. So given our quadratic function, f of x equals ax squared plus bx plus c, if a is greater than 0, then it opens up. Okay, so you can think of it as smiling. If a is less than 0, or another way to think of that is negative, it opens down. This is upward, downward. Okay, this point here is called the vertex. It's the highest or the lowest point of the parabola. And so if we have a parabola that opens up, okay, so we've got it smiling at us, it has a minimum. Okay, and the minimum is at the vertex. If our graph is frowning at us, if it's opening downward, then we've got a maximum at the vertex, and you can see that's the highest point of the graph in that case. Okay, so example 1, determine whether the graph of the parabola opens upward or downward, and if it has a maximum value or a minimum value. Okay, so in this case, a is equal to 8, which is greater than 0 or positive. So this parabola is going to open upward. Okay, and parabolas that open upward, and this is not something you necessarily need to memorize, it's something you can visualize. The function has a minimum value. Example 2, determine whether the graph of the parabola opens upward or downward, and if it has a maximum value or a minimum value. Okay, so in this case, a is equal to negative 5. So this is going to open downward. Okay, and parabolas that open downward, just estimating, it's going to have a maximum value. Okay, so visualizing these is really helpful. Example 3, okay, so determine whether the graph of the parabola opens upward or downward, and if it has a maximum value or a minimum value. So in this case, it's not written in standard form like we talked about, but we can still determine if it opens upward or downward by looking at what's in front of the x squared. Okay, so you could multiply this out if you wanted to get it into standard form. If you were to do that, remember that x minus 2 squared means x minus 2 times x minus 2. So what you would do here is you would distribute or use FOIL, minus 2x plus 4, and then there's still a negative in front. So this would be x squared, negative 2x minus 2x is minus 4x plus 4 plus 4, and then you could distribute the negative sign to everything, which would give us negative x squared plus 4x minus 4 plus 4, which is negative x squared plus 4x. Okay, so you could do this. And then you would see here that there's a negative, so this is going to open downward. Okay, and if it opens downward, then it has a maximum value. Okay, you could have also determined it from the negative sign right in front of the parentheses, but I wanted to show you what it would look like if you multiplied it out. Example 4, determine whether the graph of the parabola opens upward or downward, and if it has a maximum value or a minimum value. So we've got it written, this is called vertex form, which we'll talk about later. Again, but notice if we were to multiply this out, okay, the x squared would be positive, and then we'd be multiplying it by 3. So that's also another way to determine that that number in front of x squared is positive, which means that our graph is going to open upward, and if it opens upward, then there's a minimum value. Okay. Thank you for watching. If you have any questions, feel free to reach out to me.